What's up, creators? So in the previous two videos, we created an app that looks like this using the block pattern. We covered most of the basics of it, so if you want to check that out, both of the links are going to be in the description. But today what we're going to do is add multiple blocks to the application. So this is what the structure of the app looks like currently. We have the actual app going into block provider, which uses block A, and then we go into our home screen, and inside the home screen there's a block listener and a block builder. What we're going to do today is we're going to be using multiple blocks, and we're going to instantiate the blocks here. How we're going to do that is we're going to add a multi-block provider at the top here, and we're also going to add a multi-block listener on a different screen somewhere, so we can listen to activities of multiple blocks. So with the second block, our architecture is going to change a little bit. So there we had block A, and now let's add another block, call it block B. Like I said, at the very top, we will have our block provider now. But instead of just being a block provider, it will be a multi-block provider. So this will create instances of multiple blocks for us. And that will lead into our whole app, because we want to provide those blocks to more than just one screen. Then this app will go into a home screen, which will have the same thing as it had before, a block listener. My typing got ugly there. And a block builder. We're also going to add a second screen. Inside the second screen, we're going to have a multi-block listener. So we can listen to block A and block B. Then this multi-block listener will have two block builders underneath it for this, so it reacts to the state of the two individual blocks. So here we're going to be passing block A to the multi-block provider and block B, and then the home screen will still be listening to block A, and it will still be building according to block A, just like we had before. But now also this multi-block listener will be listening to both block A and block B. This got a little ugly, but these block builders, so this first block builder will be listening to block A. Let's say block A, and this block builder will also be going to block B. So that got a bit messy, and let's just write out what blocks each one's going to be using. So multi-block provider will be using block A and B. The home screen will still be using block A just like it was previously. Same with the block builder. But the multi-block listener will be using A and B. But the block builders underneath it will still only be using one block. And that's how the new app is going to look. So let's get into the code. Hopefully that will clear things up if it hasn't yet. We'll also be looking into the interactions between these two and how you can have multiple blocks interact with each other. So let's get into the code, and hopefully that helps you understand it even better. All right, so here we have the app from the previous videos. So right now, this block provider is only providing a block to one screen, and that's the home screen. So let's say we want to add a second screen here. Our block won't be provided to that screen. So we need to move this block provider one widget above. We can swap it with parent like that. It doesn't work out well every time, but we can make it work. So this should still act just how it was before. increment works, everything works. So now let's turn this into a multiple block provider so we can have multiple blocks instantiated here. So we can change that to multi-block provider. We're going to need a provider's argument. And here we're going to pass our block provider, which is going to look just like that. We can pass it here, and then we can remove it from here. We get an error because we need another bracket here. So there we go. Now we're providing the block. Everything should still work as before. But now we can make a second block. So I think my preferred architecture is to have a separate folder for all your blocks. So everything can be managed from one place. And then we can move this block that we had created before into the blocks folder. And let's also rename it to counter. Then we're going to have to fix everything up here. There we go. And then here as well. There, just needed a reload and it should work. So now that we can add another block. Let's name this block random. Want to use that? Sure, why not? So in the counter folder, that's not what we wanted. We want it in the blocks folder. Yes. Move it, and let's rename it to random. For our random block, let's just have one state, keep things simple. If you're missing what we're doing here, make sure to check out the other videos. I go through all this in detail. And in here, let's have a random number. We'll need to pass it to the state. And then we'll also want to put it in the props so we can make sure we can check whether it's equal and stuff. So now in random block, we have a problem because we don't have random initial anymore, but we can do random state with value 0. So now we have our state and our block almost set up. Let's add one event. This event will be called generate random, and it extends random event. We'll want to add the props in here just like before. So we have our event generated, and then we have our states done. And we can add the logic right away because we know what we're going to want it to do. We're going to want to generate a random number every time generate event happens. So how do we generate a new number? So if event is generate random, I want to do random equals random. Int rand equals random dot next int. I want it from 0 to 20. Keep it simple. Then we want to yield a new random state with a random value of rand. So every time this event happens, we'll generate a new state with a random number. Pretty simple. So for the screens, we wanted we drew up in the OneNote. We want to add a new screen. We'll just call it second screen, just to keep it simple. New file second.dart. So for this screen, I already know we're going to need a stateful widget. So let's add the capability first to get to that screen. In the home, just in the app bar, I will add an action with a flat button that says next, and on pressed, we want to navigate to a new screen. Push material page route and type builder context, and then second screen. There. If you're not sure about how the navigator works, there's a video about that as well. Make sure to check it out. So on the second screen, I'm going to set up a quick UI without the block implemented, just because it might take up some time. Okay, so here we have a simple UI. We have A value, B value that will come from each of the blocks that we have, and then we have a total number, and then a button to increment and a button to get a random one. So the A right here should be the same value as the block in here. So we're going to use the same state for this A value from the counter block that we instantiated in the multi-block provider. For the random one, we're also going to display a state with B. And we're also going to get a total value of Y at the end. So first, let's set up the block that we already have. Let's wrap this in a new widget called the widget block builder. It doesn't want to come in, that's fine. We'll just take all of these so we don't have to deal with that anymore. I don't think we need the second screen, but we will need the counter block. So we have a block builder. Inside that, we want to add a builder class, and then build. We just want context and state. And then we want to return a text with the state, counter, and then put it to a string. And for this block builder, we want counter block and the counter state. So we have 5 on here. We can see we increment it. We don't have that enabled yet, but if we increment it from here, we'll get to 9. We'll go back to that screen. We'll still have 9. So the states are all synced up for that. Now let's add a second block with the random block. So here, let's just copy paste this. Have a block builder for B as well. What happened there? And let's do random block and then random state. And this shouldn't be counter, should be random. I think we might need to reload it. No, that's wrong. In the main, we only instantiate a counter block. We do not have a random block just yet. But that's fine. Since this is a multi-block provider, we can instantiate a random block as well. There, now we got both blocks. Go over to the next screen, it should be 0, since our default event, when we initialize to 0, and since we don't ever generate a new random number, we will always just see 0. But let's fix that. Let's have a generate function. So here for random, actually let's go in a row, make the increment work first. So how do we do that? Since we have a block provided to us, we could use block provider. No, not block provider, block provider dot of context add and you can add increment event. If we save it, we should see that this button now works as well. Wrong. So that happened because we didn't specify which block we wanted. We need to specify that we want the counter block here. So once we have the event, we should be able to increment this counter, get to 7, and if we go back, since it's the same state, we should see the same numbers. We can decrement this, and we should see that change here as well. So let's do the same thing for the random. I'm going to click the random button. We want to get the random block, and we want to add a generate random event. So now when we click this, we'll get random numbers. We go back, random numbers should stay there. So now we have these separated out. It works good. But let's say we want to update this total every time an event changes. So that wording isn't really correct because we don't really want blocks interlacing using events. But another event can be started upon a state change from a different block. So basically what I'm saying is that two blocks don't need to interact directly with each other. I think with good architecture, if blocks need to interact with each other, we'll have block A, it spits out a state. We can listen to that state. We can listen to it. And then if it needs to be, we can send another event to a different block. And that's kind of what we're going to do here. So let's say we want to listen to both of the blocks that we currently have. We want to wrap this in a widget called multi-block listener. And in here, we'll see we have a problem. We don't have any listeners defined. And we can listen to both of the blocks that we have created. How do we do that? So we have block listener. We have the counter block. And we have counter state. And then we can add another one. So this child doesn't need to be here because the child's already defined there. We can add another listener, block listener, with a random block and a random state. Once again, we don't need this child because for multi-block listeners, our child is defined right here. So let's say when we click the increment button, we wanted to also give a new random. I don't know why you'd want to do that, but let's just do it for the sake of learning. So in here, we could have another block provider, not block provider. We could have a block provider dot of, and we want the counter, the random block in this case, and we want to add a generate event. What did I type in wrong? Generate random. Now, every time we click this button, it should also update the random one. See? Random still works. This does both. Everything's all synced up here. You can decrement back down, and this will update as well. So now we have multiple listeners. We have the two block builders with their states being updated. But then how do you create a total? So there's really two main ways I could think of doing this. One, you can set up another block, call it total or something. And then after an event is generated here, you can add another event that calculates a total, then returns a state, and you just output the state here. I think that's a little bit excessive for this app, since the total, like the adding together, is only going to be on this screen. It's not going to be on multiple screens. It's a very simple app. So we're just going to use a normal set state. So let's define a variable called inTotal. And then what we can do is create a function called updateTotal. In this function, we'll do total equals block provider dot of. We'll use the counter block, and then we'll do state counter, and then we'll just do a simple add of that as well as the random number, random block, and here it's going to be random. For this, let's put it in a set state, and then we can move this up here. So there we go. Down here, we can have a total, not toString. It'll give us null at first. Let's set it to, we don't really want it to be null, let's just set it to 0. And then after our listener, when an event happens, let's update the total. And if a random event happens, let's also update the total here. And there you go, let's check it out. So 12 plus 11, 23, random numbers generated, everything seems to be working. Still have one problem. When we come into the screen, it's incorrect. So here, let's add an override for did dependencies change. And simply just call update total if you go into the screen or leave the screen or anything. There we go. So now all the states are synced up. We have 15 and 3. We decrement here. We'll get, let's go even negatives. We'll have -3 plus 3 equals 0. The random number, everything seems to be working. That's pretty much it. One little tip. Let's say you don't want to write all this out every single time. You can do counter block. Let's do that. And you can set it to be equal to this whole section. But there's no context, so you need to do it in here. So define your counter block and initialize it in the when dependencies change. But you'll see you have a little error here called close instances of darkcore.sync. This is a well-known problem. It's a problem with the linter. You can see here's a open issue in the block pattern package library. It's about that darkcore sync. Felix Angilov, the creator of Bloc, says this is a false positive in the Dart linter. So there's a way to disable this if you want. Let's just use that. Why do we want to use it? Because it looks a little bit nicer when we do this. It's a little bit shorter and cleaner. But what you can do is you can add a file here called analysis_options.yaml. And in here, you can define linter, then rules, and you can do hashtag close_syncs. And now, if we go check out the second screen, that should be gone. Not too sure how that works, but it just disables some linter options. So that's a little trick if you want to use that. However, not sure if this is the best thing to do since you won't get that error for places where it's actually an issue. So use that with your own discretion. That's pretty much it for this video. This code will be on GitHub if you want to check it out. If you have any questions or anything, leave it in the comments. And if you enjoyed it, make sure to like, subscribe, and share the video. And thank you for watching.